All right, hello folks. Thank you so much for having me at Jacksonville University. And I want to talk with you today a little bit about the show I have in Alexander Brest Gallery called A Collaboration with Computation. And in this brief presentation, I am going to go through a little bit of the process behind the works in the exhibition so that you can see how I've arrived at some of those forms. The process I use is somewhat unique and maybe different from the typical art processes you're used to, so hopefully this will be somewhat enlightening for you. Most of the work that I do is designed in code on the computer. I use a couple different programs to write algorithms that allow me to create three-dimensional and two-dimensional forms. I like working in this way because it allows me to rapidly iterate through a number of design ideas. Well, it can take a significant amount of time to write the algorithm initially. Once it's set, I can tweak parameters to create a number of variations on a form extremely quickly, so I can see like the breadth of possibilities in a particular algorithm. Excuse me. Being able to adjust those parameters is something we call parametric design. The other benefit of working this way is that it's usually pretty easy to translate from the computer-generated 3D model into a digital fabrication process. I like the digital fabrication processes because, again, it's time efficient, but also the resultant pieces are usually quite lightweight compared to other materials, which means you can save a lot of money shipping those projects around the country and around the world. So I'm going to talk about, I think, 4 pieces in the exhibition and walk through the processes behind them. I'm going to start with fields, which are the 6 two-dimensional compositions on the walls. These pieces, I think, are clearly inspired by Mark Rothko. But instead of using oil paint, I'm using archival inkjet prints. And so let me tell you about how I go about designing these compositions. I take the canvas and I subdivide it into a series of smaller rectangular regions. For each composition, I randomly select a color scheme, and those are very broad color schemes. So I might, one might be analogous or complementary or quadratic or something like that. It'll pick a base hue and then determine the other hues in the composition off that base hue. And then in each rectangular region, I create a randomly walking line. And what that means is there's like a point, and then it randomly selects another point proximal to that point, connects those with a curve, and then another point, connects those with a curve. And what gives the compositions a fuzzy kind of outline is the lines can leave the region that they're in, but they have a very strong desire to stay within the region. So if they leave the region, the further out of the region they get, the stronger the urge for them to go back towards the center becomes. Each line in the composition too is slightly different from that base hue of the region to give it some variety. The lines all have a little bit of transparency in them too. So in the gallery, I've got the prints, but the piece can run on a monitor as well. And so this little animation shows you it just can run indefinitely, creating dozens and dozens and dozens of different compositions from this algorithm. Each one is unique, but share similar properties. Next piece I'm going to talk about is specimens proteins. These similarly inspired by sculptor Bruce Beasley's work. The algorithm I use for these is to take an 8-inch by 8-inch by 8-inch cube, create 10 random points within that cube, connect those points with a continuous curve and then sweep a square profile along that curve. And I'm going to show you a little bit of what this looks like on the computer side. This is the code. It's written in a language called Grasshopper, which is a visual programming language for the Rhino 3D modeling platform. You can see adjusting the seed is like just spinning up the randomness of it. So using the other parameters as set, basically changing the location of the 10 points in the cube to give me a different line composition. And then I can change other parameters like the size of the polygon that's getting swept along the path, how many slides that polygon has. I could do 5 sides, 6 sides, etc. And if I want to round the corners of that polygon as well. And of course, I can change the number of points in the cube too. And so I wanted to, so this is the simplest algorithm I have, so I'm going to walk through it briefly just so you can have an understanding of how this works. Here I'm making the box that the 8-inch cube that the elements will be within. I'm populating that randomly with my 10 different points and adjusting the randomness of that population, connecting those points with a curve and closing the curve here. Down here, I'm making the polygon with the number of sides and the radius and the fillet as needed. On the curve, I am making a frame, so I'm picking the starting point of the curve and generating a plane that's perpendicular to the curve, so as if the curve was like coming directly out of that plane, and then orienting my polygon to the curve on that plane, which allows me to sweep it evenly along the curve and then generating the preview. And here's a little video of my ancient 3D printer generating these forms. Now, in most of my other work, I'm somewhat of a material purist, but the plastic 3D printedness of these objects just does not appeal to me. It reveals too much of how they were made. The tool marks, in a sense, are too strong. So I've done a lot of experimentation with different ways to apply traditional sculpture finishing techniques to the 3D printed objects. So in another series, I've used a variety of different wood finishes on the plastic. On these ones, the proteins and the pods, I coat them with a bronze powder suspended in an acrylic binder, and then I can use traditional patinas on them. So they end up being incredibly lightweight objects, but that have a very heavy visual look based on the finish applied to them. So pods is the next piece I'll talk about. Quite similar process to proteins, but instead of extruding a shape along a path, I'm making a stack of circles with an even spacing between them. The circles increase and then decrease in diameter. I distort those circles by a factor to make them a bit wiggly. The lines of the circles are a little bit wiggly, or jittery, we might say. And then I rotate those circles by a degree percentage, and finally loft a surface between the circles to create the pod shape. And these have a very organic kind of feel. They might be like seed pods or acorns or something like that. So again, I'll show a little bit of how I go through creating these. So the first thing I can adjust is the number of points or the amount of distortion on the circles, the more distortion, the more wrinkled or ripply the edge, less points, a smoother surface. Similar to that, the range of distortion, as I increase it, makes the grooves and ridges deeper. Decreasing that makes a smoother object as well. Adjusting the radius will change the overall thickness or thinness of the shape, and you can see from this that different parameters, depending on what I'm adjusting, require more or less computation time. So one of the things I look at in designing is trying to optimize or simplify the code so that I can do that rapid iteration that I want to in a smooth way. And so for the pods, I can adjust two things in relation to the height of the object. The z-step is how the distance between each circular layer of the profile, and the number of circles is how many circles are on the object. So increasing either of those will increase the height of the object. Increasing the number of circles will make the surface more complex. Then I can also, like I said, rotate or twist the circles, which gives it a little visual spiral to it. Once I've got a set that I like, I can again adjust that random seed value to iterate through a number of different versions of the same base shape, just changing the initial randomization values for it. So the last piece I'm going to talk about are my vessels series. These are quite different from the other ones. I'm still using Grasshopper to develop these forms, but with these I start with profiles that I've hand drawn, and I'm working more with binary conditions with these to determine the shapes, and these are built ultimately with a traditional boat making process in wood instead of a digital fabrication process. So you can see significantly more complex code here, but the things I can ingest here are like the profile shape. So this you're looking at is just circles, but I can change that to be a kind of rounded triangle shape like this. This is the shape that most of the pieces in the gallery are made from. And then I can adjust other things, like do I want the profile to be the front, the same front and side, or do I want it to have that more offset look, which to me is a little bit more figurative, a little bit more interesting. And I can adjust how the horizontal elements, are they linear or logarithmic in their distribution. Again, with these, I prefer the sort of weighty condensing of them towards the bottom. And then naturally, I can adjust things like the number of vertical elements, the number of horizontal elements in the shape as well. I can change the height, etc. Once I get a set of parameters that I like, then I'll start the fabrication process on this. The other thing I build into the algorithms is the titling. So if you've seen the titles of these pieces, they look kind of cryptic. So this is showing that the material is white oak, the height is 36, the number of stringers is 20, the curvature is 4, et cetera, as I go through the different variables there. I'm going to point out these dimensions. So since I'm not 3D printing this form, I'm going to make it out of wood. I, in the algorithm, make a series of patterns that essentially makes a mold that I build the form around. And these dimensions here give me the offsets of those patterns. And in these views, we can't see them, but the profile shapes of the object are at each of those dimension points. So I project those onto wood, cut them out on a bandsaw, and then mount them to a backing beam like this. So you can see like the bottom, the top, and two profiles in the middle. I then wrap the long vertical elements on the form. They fit into the slots. The slots are determined by the algorithmic patterns, and lock those in place. And then I laminate and bend the horizontal ribs. And after those are laminated, I clean those up and then do a second round of clamping to glue those in place. And that is the basic process of how I make those shapes. Thank you very much for having me. I will take some questions. One thing people often ask is about the shapes and the forms, like how I come up with those initially. I do a lot of hand sketching, and I'm kind of fortunate in that I don't rely on the sculpture practice for my income. So I let ideas sit in my book and in my head for months sometimes. The ones that stick around and keep bothering me are the ones that get built. And then another thing people ask about is like, how do I know when I've done enough iterations, or like, how do you keep from like going infinitely with these things, because you could, right? I typically make enough objects so that I feel like I've fully explored what the algorithm can do. If I like what it's doing, I'll make more things, and if it's timely too. But typically what happens is something else will be eating at me, or I'll have another idea for a different algorithm, and I'll start working on that when I've gotten to a certain point with one of the previous ones. So like the basket forms, there's been 4 of those. The proteins, I think I did 3 or 4 of those. The pods, maybe 8, before I move on to the next form. I think another thing I'll mention about all of these works too is I'm really trying to push what the computer can do. My background is not in computer science. My background's in the fine arts. So that's the collaborative aspect of this. When I'm coding, I really feel like I'm having a dialogue with the machine. Writing an algorithm, it's only going to do what you tell it to do. That's all it can do. But when you introduce enough randomization and enough recursion and feedback into that algorithm, it feels like it begins to take on a life of its own, in a sense, and that's how it becomes like a collaboration to me. And what I'm trying to do with these shapes and forms too is to like push as much organicness into them as I can. It's very easy to make stuff on a computer that looks like it was made on a computer, right? You see these very like rectilinear things or triangle facets or stuff like that, the polygonal stuff that looks very computer generated. I want to push the language, the visual language of computer generated media as much as I can, to see like how organic can I get it, how can I make it look the way that the artist wants it to be, and not necessarily like the easy path that the computer allows. So again, thank you so much for attending my talk.